introducing the world of atoms. Everything around us, from the chair you're sitting on to the air you breathe, is made of tiny particles called atoms. Imagine them as incredibly small Lego bricks, so small you can't even see them with a microscope. Just like Legos come in different shapes and sizes, there are different types of atoms called elements. We've got oxygen atoms, lead atoms, tin atoms, and many more. These tiny building blocks are the fundamental units of matter, meaning they're the smallest pieces of stuff that still act like that stuff. For example, a gold atom is the smallest piece of gold you can have. Break it down any further and it won't be shiny and valuable anymore. Each element has unique properties that make it special. Gold is shiny and valuable. Oxygen is essential for us to breathe. And carbon is found in everything from diamonds to pencils. Now imagine you have a giant box of Legos, and you can use them to build anything you can imagine. That's what atoms do. They combine in countless ways to create all the different materials we see in the world around us. From the water we drink to the stars in the sky, it all comes down to these tiny, mighty atoms. So the next time you hold a glass of water, remember that you're holding billions and billions of tiny atoms, all working together to make something amazing. The atomic crew meet the protons, neutrons, and electrons. Atoms are the building blocks of everything, and they have their own special components. At the center of every atom is a tiny nucleus, like the inside of a Lego brick. The nucleus is made up of two types of particles, protons and neutrons. Protons carry a positive charge, like the plus sign on a battery. Neutrons, on the other hand, have no charge. They're neutral, like a referee in a game. Whizzing around the nucleus are even tinier particles called electrons. These little guys have a negative charge, like the minus sign on a battery. Electrons are constantly on the move, orbiting the nucleus at incredibly high speeds. It's like they're playing a never-ending game of tag around the protons and neutrons. The number of protons in an atom determines what element it is. For instance, all carbon atoms have 6 protons, while all oxygen atoms have 8. The number of neutrons can vary, creating different isotopes of the same element. And the electrons, well, they're the social butterflies of the atom, responsible for forming bonds with other atoms to create molecules and compounds. Think of it like this. Protons and neutrons determine the atom's identity, while electrons determine how it interacts with others. Atoms interact with each other through bonding, involving the sharing or transfer of electrons. Similarly, molecules can interact with other molecules through various types of chemical bonds and intermolecular forces. Chemical bonding refers to the attractive forces that hold atoms together in molecules or ions. Intermolecular forces, on the other hand, are the attractive or repulsive forces that exist between molecules. These forces are responsible for many physical properties of substances, such as their boiling and melting points, viscosity and solubility. Electron shells, the energy levels of atoms. Remember how electrons are always zipping around the nucleus? Well, they don't just fly around randomly. Instead, they occupy specific energy levels called electron shells. Think of these shells like different orbits around a planet. Each shell can hold a certain number of electrons, and the electrons in the outermost shell are the most important for bonding. The first shell, closest to the nucleus, can hold up to 2 electrons. The second shell can hold up to 8, and the third shell can hold even more. Atoms are happiest and most stable when their outermost electron shell is full. It's like having all the seats on a bus filled, everyone's comfortable, and there's no room for anyone else. Now, some atoms have naturally full outer shells, like the noble gases helium and neon. These elements are very stable and don't like to react with other atoms. They're like the independent kids on the playground who prefer to play by themselves. But most atoms don't have full outer shells, which means they're always looking for ways to fill them up. And that's where bonding comes in. By sharing or giving away electrons, atoms can achieve those coveted full outer shells and become more stable. In the end, atoms are everywhere, and they make up essentially everything we see in the world around us. From the smallest bacteria to the skin on our bodies, atoms are the literal building blocks of matter, forming various forms of life. So remember, the next time you sip a McFlurry, climb Mount Everest, or take a big chunk of a juicy Big Mac, just know that they're made up of small particles called atoms.